Hello, today we are doing Chapter 5, Section 6. Our essential question is how can you graph a linear inequality in two variables? It's really not that bad. So, first thing we're going to start off with is to tell whether or not an ordered pair is a solution of the inequality. Remember, an inequality is almost like an equation, but we don't have an equal sign. We either have a less than or a greater than. We could also have a greater than or equal to like we have right here. Here we only have a less than. If there was a line underneath it, it would be a less than or equal to. All you're going to do is take that ordered pair, plug it in. X is going to be -1, Y is going to be 9. And you're asking, well, does that equal or is that less than -3? Then you get 7 and -3. Well, 7 is not. That's why they put that line through it, less than -3. So I would say it is not a solution of that inequality. An equation has one solution. An equality is going to have many solutions because of a shaded region, which we'll talk about in just a second. Let's go ahead and test out problem number B. So we've got x minus 3y is greater than or equal to 8. We're going to plug in x equals 2 and y equals -2. And you get 8 is greater than or equal to 8. And that one's going to work out because we have that equal to sign. If we didn't have that with us, then it would be a no. But since we have that, yep, it is a solution. All right, so like on that first one, you plug in -2 in for x and 2 in for y, and ask yourself, is that greater than 0? Well, if you add them together, you're going to get 0 is greater than 0. That's not true. They're equal to each other. So on that one, I'd have to say no. On number 2, when you plug those in, you get 0 is greater than or equal to -5. Well, that's not true. So that one would be a no. Go ahead, hit pause, try problems 3 and 4 on your own. Both of those are yeses. All right, let's talk about actually graphing them now. You're going to graph the boundary line. That's like your equation. You'll use a dashed line for a less than or greater. Use a solid if it's got that equal sign with it. You're going to do a test point. And I'm going to talk more about that in just a second. And then if the test point works, you'll shade that side. If it doesn't, you shade the other side. And again, let's do a couple examples. And I then come back and revisit this core concept, and that should make more sense. So on this first one, we have y is less than or equal to 2. So my boundary line is y equals 2. That's a horizontal line. 0, 0 is usually a good test point. So you plug on this one, 0 in. Well, and then you ask yourself, is 0 less than or equal to 2? Yeah, it is. So that means I want that test point shaded. So I would shade down below. One thing that I would have thought about is less than. Less than always means lower. So a lot of times I'll put my writing utensil on the line. If it's less than, you just go lower, and that'll also tell you which direction to shade it. So that means that anything shaded is a solution. So this point right here of 3, 0, that's a solution. 3, 1, that's a solution. -1, -1, that's a solution. 3, 4, that would not be a solution. So on this one, we have -x plus 2y is greater than 2. We want to go ahead and graph that, put it into slope-intercept form, add x to both sides, divide by 2. So my y-intercept is 1. My slope is 1/2, up 1, right 2. And we're using a dotted line because there's no equal. My test point is 0, 0. So if I put 0, 0 in there, I get 0 is greater than 2. Well, that's not true. That's why we have a line through it. So I want to shade the side that does not include 0, 0, which would be above the line. And the way I would have really looked at that is that's a greater than. So I would have put my writing utensil someplace on that line. Greater than, you're going to go up. All right, take a second, graph these on your own, and then check yourself. So you're probably going to need to hit pause and then check yourself. All right, let's do our word problem. You can spend at most. So when I say something like at most, I automatically start thinking about inequalities. Because I can spend less than that, but I can't spend any more. I can spend at most $10 on grapes and apples for a fruit salad. Grapes cost $2.50 per pound, and apples cost $1 per pound. I want to write and graph an inequality that represents the amount of grapes and apples you can buy, and identify and interpret two solutions of that inequality. So I'm going to have to graph that. I know the price for grapes and apples, and I know how much money I can spend. So my plan is I want to make that inequality. I'm going to graph it, and then I'm going to make some statements based on that graph. So if I were to think about this, the cost per pound of grapes times the number of pounds plus the cost per pound of apples plus the number of pounds has to be less than how much I can spend. Less than or equal to. So X is my grapes, Y are my apples. When I do that, I get 2.5x plus y equals 10. Or if I put that into slope-intercept form, negative 2.5x plus 10. And I'm only going to use this first quadrant because I cannot have a negative amount of apples and I can't have a negative amount of grapes. So now I'm going to use 0, 0 as my test point. Plug it in. I get a true statement, so I would want to make sure 0, 0 is shaded. And again, the way I would look at that is it's a less than. I put my pencil on that boundary line. Less than, I go low, and that'll tell me which side to shade. So I need to make some interpretations. So what I means is anything in here is a solution. So I can buy 1 pound of grape, 6 pounds of apples. 2 pounds of grapes, 5 pounds of apples. You could also have gone right here, 1, 4, 3, 1. You could not have done 1, 8 because that would have been outside. So there's actually a ton of solutions inside that shaded region. All right, try this one on your own, and we'll see how you do. They give you that equation in slope-intercept form, but you can, at most you can spend is $12. So red peppers are $4. So I would think of that as 4x. And tomatoes are 3, so 3y. And that has to be less than or equal to 12. Subtract 4x, then divide by 3. That's how they came up with that equation. All right, hope you enjoyed.